Now let's get into some of these really tough topics. And this is in many ways a very important question to ask. How does backpropagation work in deep learning? And what are some common challenges in implementing backpropagation? So let's talk about backpropagation. And I think in many ways, this can be easily classified as the heartbeat of deep learning. And honestly, I believe it's the reason why even modern AI works. Imagine you're training a neural network. It's almost like teaching a robot to guess things. Is this a cat or is this a dog? And the robot takes a broad set of guesses and it gets them wrong. And now it needs to figure out how to improve itself. That's where backpropagation comes in. It's the mathematics that helps the model learn from its mistakes. Another way to describe this is think of it like playing darts while you're blindfolded. So you throw, you take off the blind, see how far off you were, and then you figure out how to adjust your aim for the next round. And that's exactly what backprop does for a model. It looks at how far off the prediction was, and that's called the loss, and works backward to adjust the network's parameters so it does better next time. So let's understand the flow. The model makes a prediction. It's the forward pass. It compares that to the true answer, helping it calculate the error. And then it goes backwards through the network using derivatives to figure out how much each layer contributed to the mistake. And this info, which is called the gradient, tells each layer how to adjust its weights. Now, these gradients are like hot or cold, and they're just signals, and they're guiding the model towards better guesses. And the process repeats over and over, tweak, test, correct, until finally the model gets really good. Now, here's the interesting twist. Backpropagation isn't even new. It was developed back in the 1980s by folks like Geoffrey Hinton and David Parker and others, building on work that kind of goes even further back to the 1960s. But why Hinton is important is that he was key and critical in applying backpropagation to deep learning. Before backprop, neural nets were quite weak. You could only sort of train really shallow models, like 1 or 2 layers deep at best, and they could not handle anything more complex than that. And there was no solid way to tell those earlier layers how much they were contributing to the overall mistakes that those models were making. So the models would either get stuck or they would just forget what they learned. And then backpropagation came and it changed everything. It lets us send detailed error signals all the way through that network. And so now suddenly we've become deeper and more complex models have become more trainable. And that's why backpropagation is such a big deal. It's like discovering compounding interest in finance. It's a small idea, but has a massive impact. And yes, it has its set of challenges. One of those challenges is a concept called vanishing gradients. And this is where early layers stop learning because the gradient gets just way too small. And then on the opposite side, you have what's called exploding gradients. And this is where updates get too large and they, in effect, kind of blow up the model. Training is also picky. You need the right learning rates. You need good initialization and initialization vectors, and you need a lot of compute. But despite all of that, without backpropagation, we wouldn't have things like ChatGPT. We would not have self-driving cars. We would not have image generators or any of today's AI breakthroughs. So yes, backpropagation is the thing that's turning guesses into learning. And without it, your models or models in general would be just like throwing darts in the dark.